I'm Anil Kumar sharing with you a question from my student Tasfeia. So let me first thank her for this excellent question. Actually, there are at least 7 parts to this question, but I've taken up one, the very basic one, without which we cannot move forward, and the second one is my favorite. So I thought we'll discuss these 2 parts in this particular video, and if time permits, I can discuss the other parts of this question, which will help you to review all of trigonometry with just one question. So thank you, Tasfeia, for making such an excellent question and sharing with me. The question here is, Natasha is planning on going to the annual country fair in Montana. She plans on going on the famous Ferris wheel called the Swinger. The Swinger completes one rotation in 50 seconds with maximum height of 56 meters and the boarding height of 14 meters above the ground. Determine an equation to model the height of a person. And there were so many different parts, but I've taken up this one, which I'm calling now as part B. Find the possible duration when the average rate of change in the height is 1 meters per second of the person riding this wheel. Well, we will consider solution of the second part in the next video. In this video, let us get to the equation of the Ferris wheel, right? And then with that basic equation, we can move on and discuss the other parts. So what we are given here is a Ferris wheel, okay, and it is high above the ground, right? So, okay, with, let us say, the maximum, and that is the minimum, right? So let me make my scale somewhere like this. So what we have here is maximum 56 meters, minimum is 14 meters, and time taken for one revolution is 50 seconds. So we have maximum is 56 meters, minimum height is 14 meters, and time is 50 for one revolution, 50 seconds for one revolution. Correct. Now we need to find a function which can model this situation. So since we always board from the bottom, so we'll be using cosine function, and that too with the negative sign. That should help, right? So that is what we intend to do. So let us find first the amplitude. Amplitude should be equal to, let me do the calculations in a different ink now. Amplitude will be maximum minus minimum divided by 2. So in this case it is 56 minus 14 divided by 2, right? So that gives us 42 divided by 2 is 21, right? So 21 is the amplitude. Now let's find the average. That means how much high the center of this Ferris wheel is from the ground, right? So let's call that as D. Average value will be maximum plus minimum divided by 2, which is 56 plus 14 divided by 2. So that gives you how much? This is 70 divided by 2 is 35. So we have D, right? Since we have assumed that the persons are boarding, or our model will start at t equals to 0 when they board, right? So that is how it is going to be. So it is going to be like a cosine function, which as time permits it will go like this, correct? So that is how the function will move. Now since we know the time period, we can find the value of k. Now the value of k, one full revolution if we do in radians, will be 2 pi. So it will be 2 pi by time taken, which is 50 seconds. Those of you who are doing in degrees, for them it will be 360 degrees divided by 50, right? So that is the value of k, and that gives us the equation of the cosine function, which represents the height of a person on this Ferris wheel, right? So we can write the height h as a function of time t as equal to we are using cosine functions. We'll start with negative since we have started from the bottom, minus, and amplitude here is 21, so minus 21, correct, cos of k value. So if you are doing in radians, it would be 2 pi over 50. I'm not simplifying it. You should of course simplify it. Times t, right? Plus d, which is 35, right? This will be in radians, correct? Now you could have the same function in degrees also, where the equation will be minus 21 cos of 360 divided by 50 times t, this is in degrees, plus 35, right? So these equations represent or model the situation, correct? Now the next question for us is, which is kind of the most important question where we really want to get into, is find the possible duration when the average rate of change in the height is 1 meter per second of a person riding this wheel, right? I'm going to discuss the solution in the next video, but I'm giving you ample time to think about it. So when will the average rate of change of a person, average rate of change we say will be what? Let's discuss it a bit. So we say average rate of change will be what? Average rate of change will be height at two different timings, right? So t1 divided by t2 minus t1. So that is going to give you average rate of change. What you can do is, since we are just looking into any two times, it'll be easy if you take t1 as 0, the starting point, right? So from here to the next point, then it becomes a simpler question for you to solve, correct? So take your own time, find the solution of this part, and then let me know, right? What is your solution? In the next video, I will discuss the solution of average rate of change. And if time permits, we can discuss, there are 6-7 parts of this question, which are very good, just as this one. We can discuss those also. I hope that helps. Thank you and all the best.